Ah, the joys of 3D printing. Spend 20 hours making something that you could have bought for $5.
Nanook Metal, tuk tut!
Hello friends, my name is Nanok Metal and I hope that you're having a good day. Today I wanted to share with you a project that I've been working on. It's an Arduino based controller unit for a fan and some lights that I've installed into the enclosure of my 3D printer. It is operated by a panel that I've installed into the front of the enclosure, and it consists of 5 buttons. 2 buttons turn the lights and the fan on and off. Then there is a minus and a plus button that controls the speed of the fan. And lastly, I've got a preset button that switches the speed of the fan to 2 predetermined speeds. Those are the ones that I most often use. The fan allows me to control the temperature inside the enclosure and optimize the quality of the prints, but it also pushes the air out through a filter stack that I've designed, and the filter consists of a HEPA filter as well as about 10 centimeters of activated carbon material. Ideally, I would like to exhaust the air from the enclosure into the environment, but while I don't have the opportunity to do so, I have to resort to using a filter and making sure that the room is well ventilated while something is getting printed. In the original setup, I was using a remote control that came with my Arduino kit to control the unit, and it wasn't very pretty because this is a generic remote. There are too many buttons on it, and it's also completely unnecessary because whenever I'm changing something, I'm gonna be standing right there next to the enclosure, listening to things, looking at things. So I wanted to change the input to a hard-mounted panel that would be on the front of the enclosure. Let's have a look at how the electronic side of things is set up. In the top right corner you can see the Arduino Uno board. I'm powering everything from the 3D printer's power supply, and unfortunately the output of it is 24 volts, so I have to use a buck converter, that's the blue PCB at the bottom, to lower the voltage from 24 down to 12 volts. 12 volts is digestible by the Arduino board, as well as the fan that I'm using. It's a Noctua 12 volt fan, so the buck converter outputs to both of those components. The LED array that I've installed is 24 volts, so I can power it directly from the power supply. Both the lights and the fan are powered through a relay, and with a push of a button I can switch that relay on and off, kind of like a switch on your wall when you turn the lights on and off, except in this case you're not using your hand, you're using electricity to power and turn them off. As part of the code, I've added some debug statements that allow me to keep track of the state of my variables, and because during the programming phase I didn't have the Arduino board connected to the lights or the fan, so this way I was able to test out the functionality of the buttons and make sure that everything is working fine. I'm not very experienced with 3D design, so I wanted to challenge myself and create the buttons panel from scratch. I had to be quite careful with the tolerances because otherwise my keycaps would be stuck inside of their channels, and also they might not actually reach the PCB mountable button that's installed into the back of the panel. Fortunately, this software, Fusion 360, is quite user-friendly, and I'm able to change the height and dimensions of the buttons. So I've printed out a couple of prototypes and I was able to adjust those parameters, and within a couple of prototype prints I was able to get a perfect fit. So it was time to put everything together and make a hole in the enclosure into which this panel will go. I've designed the panel to be just friction fit into its corresponding hole, so there are no screws, hopefully no glue or anything like that. Therefore I'll be able to take it out if I ever need to. That meant that I had to be very careful with the final dimensions of the hole, because if I remove too much material, the panel would be loose in there and it might fall out, or I'll have to use some kind of means such as glue or sticky tape in order to make sure that it stays in there. I was very worried that in the end the panel would not fit level, so I took my time with measuring things out, and also when I started cutting out the hole, I just gave myself a little bit of extra space. It's always possible to remove material, but it would be very difficult to bring material back. The plan was to drill a whole bunch of holes and then connect them using a saw. I unfortunately realized too late that I don't have a saw that fits in there, and the only thing that I could use was a Swiss Army knife that I have. It was very difficult to use and just reminds me again that having the right tool for the job is absolutely crucial. The next step wasn't any easier because I couldn't work out how to clean the hole up and remove a bit of extra material so that the panel could fit. I had to go out and buy a chisel. Well, at least now I have it for any future projects that I might come across. I put some of that green painter's tape to show the borders of the lines that I drew, and that was kind of like a signal of where or how far I can go in removing the material. It worked out quite well in the end. As you can see, the panel fits in there, but at the same time it fits there very tightly, so I don't want to push it all the way in just yet because I still need to connect it. Oh yeah, while I was there, I've reprinted this little door stopper piece because the blue part was actually a prototype that I've designed. I think when I first installed the 3D design software, I was very proud of this simple L-shaped piece. I unfortunately didn't install it correctly because those holes are off center and the piece itself was off center in the end. So this final version is adjustable to an extent, and the center of the piece is right where the two doors meet. One of the last things that I needed to do is to connect the buttons panel with the control unit. So I've done this using an Ethernet cable because it has 4 twisted pairs or 8 wires in total. And that means that I only need to run that one cable in order to connect everything. Since I'm not running any high voltages or currents through these wires, the Ethernet cable is a perfect option for this part. You might recognize that this is actually a repurposed IKEA Lack table, and you also might know that those tables are kind of hollow inside. There is a cardboard grid that provides the sturdiness, but otherwise it's just full of air. In my case, it actually makes my life easier because it allowed me to run that cable without having to drill a whole bunch of timber. And the top of the structure is never gonna bear any weight, so I'm not bothered that I've disturbed that cardboard in there. So this is what the final product looks like. This part of the enclosure is now 100% functional. There are a couple of other things that I would like to change, but that's something for the future videos.